We are right now in Visual Studio and we're gonna start building our programs in C++. So we go to create a new project. You should have already installed C++. Okay, C++ empty project. This is what I'm looking for. Next, we're gonna call it project, add a new item. We're gonna call it first simple app C++.cpp. Okay. At first we start by including IO stream, which is the input output stream, using namespace std for input and output. Int main, this is the main access point of the program. This is where everything is called and executed. And to test the program, cout. Cout means print to the screen, to the external screen, a message. Hello world. \n means break the line or create a new line after hello world. Return 0 because this is a function. It needs to return something. Even the main, which is the access point for the program, is a type of function, so we're returning 0. And this is our first simple program. So how to comment a line? Commenting means when I need to write a note concerning the code and I don't want that code to be executed in the program, we simply type / twice, 2 forward slashes. This is a new program. Okay, it won't run. So when I run the program, the compiler won't run this line. It runs fine without any problems. When I need to create a multi-line command, the limit them with /* and end it with */. So this program executes a simple code, etc. Okay, you can add as many lines as you want, and you won't create any error because the compiler would neglect these lines that are written between these two delimiters. Now, creating a variable. So, at first, what types of variables you have? Integer, so int x equal 10. Integer is, an integer number. Simply put, coded on 8 bits. You have double means it is a real number, a long real number, equal 30.567. Float, like double, but it is smaller than that. Okay, we'll call D here. Float f equal 4.589. Bool, it means Boolean, and it takes two types of values, either true or false. Char or character, so it can store only one character, A or A, capital A or C, M, and string. String is an array of characters. You can consider it like that. It stores many characters. So string S equal, this is my string. And if we want to output any of the values, you simply type cout x. Okay, let's run it. So you have on this line the value of x displayed. Or cout b, which will give you true. Of course, true is 1 in C++, false is 0. We can embed them within a string like this. So the value, you can write the value for float f is f, and I can end the line. It is the same thing as writing \n. You can write end line to break the line at the end. The value for float f is 4.589, which is true. These are the different data types. Of course, we might have others. We're gonna also address that at some point. Okay, to backtrack a little bit. So what is a variable? A variable is a storage point, a container of a certain value. So x is a variable and it has a data type. Data type is the type of storage the variable, which is the container, is storing in the memory. So for int, the storage would be different than for double, basically in size mainly, and formatting for that data value stored in the variable. So when we talk about float, a float value is a real number. It has fraction within it, unlike the integer. So it needs a different storage within the memory, and it has a different formatting for that data type. Same thing for string. A string can store multiple characters versus one character data type. One character variable C of data type character only stores one character, only one. Now let's talk about operators. Mainly mathematical operators, assignment operators, incrementation. Okay, so let's declare again int x is equal to 5, int y equal to 3. Okay, so what are operators? I will declare an empty integer variable z. Operators, math operators are plus, minus, multiplication, which is adding, subtracting, multiplying, division, modulus. Modulus is the remainder of a division. Z would hold the value that we get from the mathematical operation between x and y. So z equal x plus y let's see what z would be equal. I can add end line at the end. Okay, so z equal x plus y. What will happen is x will be added to y, or the value stored in x added to y, x plus 3, and this will be assigned. This is why we call equal the assignment operator. The outcome will be assigned to z, which is also a placement in the memory that has been allocated for variable z, which is an integer. This is how the compiler would know what type of placement or what is the size of the memory allocation for z, because its data type is integer. And the addition gives us 8. Same thing for multiplication. So if I type, let's remove z, c out, x times y, it will give us the multiplication, or 15. X minus y, 2. And finally x divided by y, 1. Now, of course, you already know that the division here would not only give you 1. If we're talking about float values, it would give you 1 point something, right? There would be a fraction. However, since we have integer variables here, it is assumed that the value that is produced would be an integer, given the fact that both x and y are integers, so it would truncate the fraction part. If we had a float x and y, it would give you 1 point something. You would get a fraction returned by this value. Okay, another type of operator, as we mentioned, is x modulus y. which gets me the remainder of the division, meaning that you divided 5 by 3. It's not a perfect division. It doesn't give you a clear-cut answer, not like 6 divided by 3 would give you 2. There would be a fraction, a remainder. So this would return back the remainder of the division. And the remainder here is 2. Okay? So, another operator is the increment. What is the increment? Let's use x. Okay, so x plus plus, what does it mean? Take the original value of x, add to it 1, then store it back in x. It is the same as writing x plus equal 1. So it would give you 6, okay? But we have actually updated the value for x. The answer is 6. Okay? You have the Boolean operators. What are the Boolean operators? So, let's say value 1 or B1, Boolean 1 is equal to true. Boolean 2, and we need to declare the data type as Boolean. Boolean B2 is equal to false. B1 and B2, both conditions need to be true so that the outcome would be true. Otherwise, if one of them is false, the outcome would be false. So basically, B1, which is true, you can equate it to 1. True is the same thing as saying the value is 1. False is the same thing as saying the value is 0. So B1 and B2, and by the way, the and, denoted here by double ampersand, is like a multiplication operation. So true and false would give you false. Why? Because 1 multiplied by 0 or 0 multiplied by 1 gives you 0 always. Only when both of the conditions are true, when both of the conditions are 1, it would give you back 1. So if I run it, it would give me false. It would actually give me false in all the conditions except in one condition when both of them are true. So if either of them is false or both of them are false, it would give you back false. Now, if we type B1 or B2, and this is how we write OR, the OR operator, double pipelines. So B1 or B2, it means that either one of the two options needs to be true, or both of them can be true, so that it would give me true. It is the actual opposite for the AND operator. Only if both of them are false, it would give you false. Otherwise, it will always give you true. So, if one of them is true, or both of them are true, it would give you true. Otherwise, it would give you false. Now let's talk about string operators. I'm gonna declare two strings. String name 1 equal Jane. String and 2 equal Joe. I can concatenate both of them into one string. Let's declare string n3 equal n1 plus n2. Out n3 and line. Of course, I can also concatenate them to an empty space. You simply type n1 plus empty space plus n2, and it would give you the same thing except with a space between these two strings, so a more neat output. Another thing I can do with a string is, let's say I have a string. He claimed to be victorious, but victorious needs to be within two double quotes. Now, as you see, it has produced an error. Why? Because a double quote is a special character that marks the beginning and the end of a string declaration, of a string value within this variable. But how to use these double quotes as actually ordinary characters instead of special characters? we simply use a backslash to cancel the special character. You would get a string in which victorious is mentioned with the double quotes. So we negated the effect of the special character. We fixed the problem. As we mentioned before, a string is actually a string array of characters. It is an array of characters. So it is accessible. In other words, if you see here n1 equal Jane, it is actually an array of characters indexed from 0 all the way to 3. 0, 1, 2, 3. So basically, let's say I want to get the value of this array. And by the way, each character is an element of the array. So to get the element which is at this position, 0, 1, 2. Again, every array is indexed starting from 0. So 0, 1, 2, this would be n4, and this is how we refer to only this character within the string. You open two square brackets and you place two to address or to tackle this value here, which is at position 0, 1, 2. Yes, it is at the third position from the left. However, given the fact that we index characters starting from 0 in an array, actually we index starting from 0 all the way to the end. So if I run it, it would give you the letter N. Oh, I'm sorry. Actually, it is N1, not N4. Also, another thing I can get is the size or the length of the string, meaning how many characters are there in the string. So if I type n1.length, it will give me the number of characters in n1. So if I count them, 1, 2, 3, 4, it should give me 4 characters. And this is important when I'm looping through this string to get a specific value. We're going to talk about that afterwards. Also, I can get a string value as an input from the user. Let me remove all of that. We're going to get an input from the user. So we're prompting the user to give us his address, \n. We're going to store this address in a string variable initialized at empty string. You live in address, end line. Okay, another thing we're gonna do is extracting a substring, meaning a part of a string we're gonna extract by working with the indexes of the string, because the string can be treated as an array, a char array or character array. So string part equal text. Okay, we're gonna get this within the string, which starts at index 3 and has 4 characters. So text dot substr 3 and 4 characters starting from index 3. Part and line. We've gotten the part this from the entire string. Okay, let's get the word dream. It starts from index 8 and has 5 characters. And it gives us dreams, okay? Text.find. Finds means find for me the occurrence or the position of the first occurrence of a character. So since it is a position, we need to place it within an integer value, okay? So the letter D is located at index, which is the position 8. Okay. Okay, let's work with conditions. Let's say we have a value, a grade value, grade equal whatever. Let's say that the value is 55, okay? Now, I want to create a condition and to test the value of grade. If grade is greater than 50, let's say, then we're gonna tell the user that he passed, or the student, in such case, that he passed the test. If it is equal 50, then we're gonna tell him you're on probation. Otherwise, we're gonna tell him you failed. This is how we write the condition. If grade is greater than 50, we're gonna print a message. Congratulations, you passed. You passed the test. Else, if grade is less than 50, then I'm gonna apologize and tell him I'm sorry you failed the test. Now, if it's not greater than 50, neither less than 50, then definitely it is equal to 50. So no need to write it as another condition. No need to write again else if. We simply write else. Else means otherwise. If none of the other conditions is satisfied, then definitely grade is equal to 50. See out. You are on probation. Let us run the script. So grade equal 55 in our case. Congratulations, you passed the test. Okay? Let's work with switch case statement. What switch case does is placing a condition that is among multiple options. If one option is selected, then the return will be something. If another option, something different, etc. Let's start with declaring 3 strings that will have different shapes. So string triangle is equal to some form that is like a triangle. String square equal 2 square brackets. String circle okay. I'm gonna get the input from the user, so let's at first prompt the user, type T for triangle, S for square, and C for circle. C input. Okay, let's declare char C. Okay, Cn C. Now this is where we're gonna write our switch statement. Switch C. Case if C is equal to T, then what we're gonna do is say out triangle and line. Break, to break from the case statement. Other case, case S, if the user types S, we're gonna output the square, okay, and line. Break, and break would get me out of the switch statement once a condition has been met. Case C, circle and line. Finally, default, meaning that if any other option has been given that is other than T, S, and C, we're gonna output a message that this option is not available. Also break. So let's run the program. If I type T, he gave me the shape of the triangle. Actually is missing because he's considering the other character as a special character. Let's run it again. I can actually negate this backslash by another one. So type S for square, C for circle. Let's give him C, and you've gotten the circle. This is how it works. Let's talk about loops. So let's say I want to write a program that counts from 0 all the way to 9, okay? I simply type for int I, this is the declaration clause. I'm declaring an integer I is equal to 0. Then the second one is the condition I less than 10. Finally, the processing of I plus, meaning that you need to increment I by 1 each time I loop. Now, this is called post increment. Post increments means the first time I is outputted as it is, okay, it's not incremented immediately so that we won't start by 1. Otherwise, like if I type plus I, which is the pre-increment, it will add 1 to I before displaying it the first time. But in this case, since it is a post increment, it will display I, the original value, equals 0 at first. Then once it loops, I would be incremented by 1. So the second incrementation would be 1. Okay? So say out I, and let's end the line. If I run it, it will count from 0, and as long I is less than 10, it will be counted. It would be displayed. Once I is equal or greater than 10, it will break from the loop. And you have I 0 all the way to 9. Now, what I can do is, let's say I need to break from the for loop once I reaches a specific value. So let's say if I is equal, this is how we write equal. If I is equal to 5, then, and by the way, if it is one line after if, you don't have to open and close the curly braces. So if I is equal to 5, break. It will count all the way to 4, because once I is equal to 5, it will break out. Let's check it. Once I has become 5, it broke out of the loop. Another thing we can do is, if I is equal to 5, continue. What continue does is that it skips the other lines and goes back to the for loop. So I equal 5 won't be counted. This is what it means. It will skip the number 5. So if we run it, 0, 1, 2, 3, 4, 6, 7, 8, 9. Why? Because 5 has been skipped. What continue does, once I is equal to 5, it goes into continue. It skips, meaning that it goes back from this point all the way to the for loop. It doesn't continue running the following lines. That's why I equal 5 was never displayed out to the console. Another type of loops is the while loop. Now this is how the while loop works. It's almost similar to for, but the structure and the mechanism is different. So let's say you have int x equal to 20, while it's a loop that keeps going, keeps running the script that is inside the body between these two curly braces, as long as the condition within the while loop, within the while clause, is satisfied. While x is greater than 0, say out x minus minus, meaning that decrement x by 1 each time I'm looping. So it will display all values of x from 20 all the way to 1, because once x equal to 0, it will no longer satisfy this condition and it will break out of the loop. Of course, here as well we can use break and continue, doesn't matter. So you see 20, 19, 18, 17 all the way to 1. Let me split them on different lines. I forgot to do that. 20 all the way to 1. Okay, let's talk about arrays. So let's say we need to declare an array, which is a table constituted of multiple values, and always an array is indexed starting from 0 all the way to the length of the array minus 1. Because let's say the array has 6 values. If you count from 0 to 5, it gives you 6 values. 0, 1, 2, 3, 4, 5 are 6 values, which would be the size of the array. So I'm going to declare an array, of course, has a data type. It can be string, integer, it can be float, etc. So int array, let's say the size of the array is 5, 1, 10, or let's say, 11, 12, 13, 14, 15, 5 values. If I type arr.length, okay, this is not a function for the array, size of array rather. To get the size of the array, size of arr, each integer is on 4 bytes times 5, it gives you 20. If I type size of array divided by size of int, this will give us 5, okay? Because here size of counts the number of bytes, the total number of bytes for this array. Since it is an array of data type integer, each value here is coded on 4 bytes. So 4 bytes times 5 gives you 20 bytes in total for the array. This is the size of the array in bytes. To get the size of the array in terms of number of items, you type size of array divided by the size of the data type for each value, size of each integer, which is 20 divided by 4 or 5 items. Let's loop through the array, and this is where for comes in handy, for loop. For int I equals 0, I less than size of array divided by size of int I plus plus print for me the value of the array, and this is how we access the values. ARR I, when I is equal to 0, ARR 0 means give me the value at the first position, at position 0 of the array. When I equal 1, give me the value at position 1, which is 12, etc. So let's run it. 11, 12, 13, 14, 15. Instead of writing size of array divided by size of int, you can type size of array divided by size of array 0, meaning size of the integer here, which is coded on 4 bytes. Okay, it will give you the same result because size of array 0 or size of 11, which is an integer, is 4 bytes. So it will give you the same outcome and we get the same result. In this part, we're going to work with enumerators. What are enumerators? They are a grouping of constants accessible by their names. So each constant would be a value linked to a name, which is the identifier of the constant itself. Let's say water level low equal 10, u low or up low equal 30, let's say, high or mid rather equal 50, up mid equal 60 or 70, 60, okay, high 80 or 90, up high 90, finally top equal 100, which is the top of the tank. You can consider it like that. So instead of having to remember or memorize all the values, I can address these values by their identifiers. Each identifier being a pointer to that value, so to speak. Okay, so instead of writing 10, I can write low, here up mid or up high. You see, up high is 90. It is the same thing as writing 90 basically. So it is the same as writing the actual integer value, but instead we are referring to the value by its name. Just like when you type math.py, you are referring to 3.14567, something like that, which is the constant of pi. In this part, we're going to talk about memory address and pointers. Basically, a memory address is where a variable is stored, is where the value of this variable or container is stored. The pointer is what points to that address, meaning that it is a type of variable, so to speak, that stores the address instead of the value itself. This is the main difference between both. So string name equal test, let's say, for example, we're declaring a variable. Let's go for the address or refer to the address of that variable instead of the value. We place ampersand and name instead of name. So what it gives us is the memory address for the variable called name instead of the value of name, which is test. And you will see it when we run the program. You see, this is a hexadecimal address of the variable instead of the value itself. And we can store it in a pointer. So that's the main difference between the value and variable. Now, in order to extract the value from the variable or from the pointer, from the address, so to speak, we need to do what is called dereferencing. Here's what we're talking about. So we're going to declare a pointer instead of variable that will point to name. Okay, so pname equal ampersand name, meaning that this pointer holds the value of the address of name. Okay, and you see the star symbol. So, and it needs, by the way, to be having the same data type as name itself. So in order to access the value at this address, we need to type star pname. Okay, so we need to remove ampersand pname. You type pname at first without the star, without the referencing. you will get the address. Okay. Then when you place a star in the output command of cout, you will get the value at that address instead of the address itself. That's the main difference between both. So to get the value, this is called dereferencing, by the way. We dereference the variable, the pointer rather. When you run it, you'll see we've gotten the string value instead of the address this time. So this is basically how it works. In this section, we're going to declare and call a function. Now, a function is made by a caller and an accessor. The caller is actually the name of the function by which you call the function to execute a bundle of commands or scripts within that function. The accessor is the number of arguments. It is the arguments within that function that we define so that we can process them on the inside. For example, the sum function we are showing in the middle line is actually a function that adds three numbers of different data types, depending on what you have designated. So int sum, int x, int y, this function adds x plus y, simply returns the value of x plus y. This is what the function does. It always returns a value. In order to call the function, you simply type the name of the function and you fill the arguments within. So int z equals sum. We need to fill two values, 6 and 4. Then cout x, which is sum 6, 4. You can also write that. And it will give us the sum of 4 and 6. So instead of rewriting that code over and over, you can encapsulate it within a function that you can call whenever you want. What we can also do is what is called function overloading. So as you see, I'm defining the same function or another function having the same name. Still, it can have a different behavior. Okay, so it's receiving here two different data types, which are floats, and returns the sum of floats instead of integers, which is in the upper function. It's almost like we have defined a completely different function. Okay, function overloading. The same thing, you can define a third function having also the same name, but instead of returning a float, it can return double and even have a completely different behavior. So double sum, double x, and here we're gonna make it do something completely different, which is incrementing the value of x, returning x plus plus. So float z, or yeah, we can call it from the inside immediately. First function, sum 10 and 20, 10 and 15, whatever. Second function, sum, and this is how it is distinguished. The two data types will be different. Instead of integers, we are calling two floats. This is what will designate different behavior. So we have the sum of floats here instead of sum of integers. Third option, we're gonna call sum for one double. We have one argument, so it will execute the third function, the third version of it, which will add only one to the argument. And as you see, we have three different outputs. Okay, now if you notice, for the third function it returned the same value. We need to pre-increment, but because in post increment it actually increments it after running the function, so we need to pre-increment it. Now it fixed the outcome, which means it added one to the input. Class declaration. So basically, what a class is, it is a prototype that contains members and behaviors. So for example here, class plane, all planes have the same type of variables, the same types of variables. They have number of engines, they have weight, balance, etc. Also the same behaviors. Behaviors are functions mainly. Members are variables and behaviors are functions. So for private here, you have string name, string type, int number of engines, which are private, by the way, means they are not accessible from outside of the class. Meanwhile, what we have in public is, first of all, the constructor, what we call a constructor, and we will see how it works. And we have the functions, different functions. Functions are behaviors. So all planes, take off, land, do the same things. So behaviors are functions or actions, and members are variables. For the constructor, it is for the declaration of the class, meaning that each class has initial values or specific members that have some values, right? So the constructor will initialize the class with specific values. What here we are doing is, plane is the constructor. It has, when we call it from outside, it will assign name, type, and number of engines taken from outside to the inside members. So this name equal name means the name which is inside of the class is equal to the name taken from outside. Int get engines. So since the number of engines is a private member, we need a function which is public, which is get engines, to return for us the number of engines, which is the value stored inside of the class. Get name, return this name, meaning that return for me the name of the class, the string member called name within the class. All right, so this is how basically it works. Everything that is public, it can be accessed from outside of the class, from the main function or from another class. But the variables or members that are private are only accessible from within the class, meaning from the functions that are in the class itself. Okay, so this is how we're going to declare a new class instance, meaning that out of the plane class, the blueprint, you can create multiple planes. So plane P1 is Boeing, type heavy, and it has 2 engines. Okay, you can create other planes as well. Cout, so the number of engines in plane P1, let's say, is P1 dot get engines. This is how you access the values. So we get engines, we call the function, and it returns the number of engines. Declaring a public variable. Now, whatever variable is declared in the public domain is accessible directly from outside of the class, not only from inside. Meaning that when I write the name of the instance of the class dot, I can see that a variable like this one we're declaring here would be visible. Okay, float, speed, or something would be accessible from outside of the class. So as you see here, if I write p1.maxSpeed, you see it won't generate an error because it is a public variable. So it is accessible directly from outside of the class, no problem. And I can output the value from the main function. Meanwhile, for the name, it is a private variable. It's only accessible via a function that is public, that accesses that private member to output it to the outside. But max speed is immediately accessible without a method, you see? So we can write p1.getName, number of engines is 2, and the max speed is 340, something like that. Okay, let's talk about inheritance. So basically, what inheritance does is a class that inherits from another class would get all the functions, all the methods of that class. Okay, so all the methods of that class, the parent class, would belong also to the class, the infant class that had inherited the parent. Also, these functions and methods have not been declared in the second class, they inherently become the possession of that class. Okay? So in other words, let's say I declared two classes. One is vehicle, the other is car. If car has extended to vehicle, meaning if car had inherited vehicle, okay, the vehicle class, so all the functions and methods and procedures declared within vehicle, let's say vehicle.start, .brake, vehicle.fuel in, fuel out, okay, or burn fuel, all of these would be automatically accessible by the child class that had inherited the parent, given that they need to be either public or protected. Okay, protected means that these functions are accessible from the child class, okay, only. Public means they are accessible everywhere, as we've seen before. So we're declaring class, okay, human, private string type, okay. We're declaring two private variables, public, okay, so these procedures are public right now. Eat, walk, they belong to the blueprint of human, the human class. So these are generic behaviors we're declaring in the human class. Okay, void, walk, eat, drive, you can say whatever. Okay, all of these are public, so they are accessible everywhere, not only within the class itself. So see out, the character is walking, just to show you that when we've called this function had worked, okay, had executed. By the way, in the private variables, the other private member is height. Height means how tall is the subject. Now, the other class is player. So here we are defining two classes. Player will inherit from human. Consider it as being a video game where human is the parent class and player is the child class that will inherit the parent. So this is how it can inherit it. Class player, colon public human, meaning that it is inheriting from human, okay? So string player option, these are private members for player. This is a void or a procedure for the player only, which is firing a bullet, okay? See how the character is firing, okay? But remember that player had inherited a human, meaning that within player, you will see that when I declare a player, it can actually call the human procedures. The procedures that were not declared in player, but they are proper to the human class. p.eat, which is the function or procedure inherited from the human class. It was not declared within the player class. So again, we need to focus on that. The fact is, these procedures such as eat and walk never belong to player. They are inherited from the superclass, which is the human class. And again, a class is like a blueprint, a prototype of something. So you have a class card, for instance, that contain all the behaviors and members. Members are properties, number of wheels, the color, etc. Meanwhile, the behaviors are functions such as ignite, accelerate, brake. Okay, so you see here, P has been able to call two functions or procedures, if you will, that belong to the human class, not the player class. And for the fire, fire belongs to the player class alone without belonging to the human class. All right, now as we mentioned that the parent class is the high or the superclass, and the lower class that has inherited the parent will get all the functions and methods of that class. Also, what we're gonna do here is adding a constructor to the human class and make player class inherit the constructor as well. So what is a constructor? A constructor is the one that initializes an instance of the class, meaning that among the human class, okay, within a human class, which is a blueprint, you have multiple humans or person, Joe, Freddy, etc. Okay, each person has a type. Of course, in a video game, each type would be a character, and the height, different height for different characters. So here the constructor will get values from outside, which is the instance of the class, and will update the inner private members that are type and height. So for the private variables as well, which are inaccessible from outside of the class, we need to create for them public functions or public methods that will be able to access these values to return them or update these values. Okay, so the public methods can access these private members that are inaccessible from outside of the class. And the public values that are called getSet, of course, for instance here, and getHeight, this will return the private value from inside of the class to the outside. Return this height. Okay, void setHeight. Now setHeight will update the value of the height. This is what it does actually. So set height will get a value in the accessor, which is between these two parentheses. That will be an integer value, of course. It will get that value and set the inner private variable, which is height, by that value. Okay, we'll set it to that value. So you see this dot height equal h. Void set height int h, we're getting it from the accessor, this height equal h. So within the player, now we need to make player inherit the constructor. This is how we do it simply, using human, which is the class, two columns, human, which is the second word human is the actual constructor. So let's try it within main, human h equal, or sorry, h, yeah, pedestrian, the type of the human, his height is 100. Player P, shooter, or whatever, you can call it whatever you want, and his height is 103. Okay, now look at how player can inherit or has inherited all behaviors. So p.eat, p.walk, p.fire, and p.getHeight. You can write, okay, set height. So I'm updating the value of the height from 300 to 159, which is accessing the instance of that is P, an instance of player, you see, and updating its height. And I can get the height also by the getHeight function, which is public. centimeters and line. Let's run it. You have character is string, character is walking, and we've updated and displayed the height of the player. In this part, we're going to talk about try-catch clause, which is the exceptions in C++. What try-catch is for: whenever you have an operation that is risky, that may generate an error, in order to avoid the program being broken because of that error, what try-catch does is bypassing that error, and it will keep running the consecutive lines or commands without having the program interrupted. One of the most examples of having such a problem is a division. When you're dividing x by y, for instance, and y happens to be 0, you would have an error because any number divided by 0 would return infinity. So how to avoid having such problem? You have try. Try means try that operation, try executing that operation. Catch is when you have an exception generated, it will catch it and return a message without breaking the program. So try the risky operation, which is return x divided by y. In case y is 0, it will catch an exception and display a message that you've gotten an error generated by that operation. Correct? Of course, the operation is float. The returned value is float. Float z equal x divided by y. Okay, we're gonna add to it a variable that will be filled with the error if an error has been generated. All right, let's call that function from the main. D equal divide 16 0. Let's say okay. We need to define the data type of D. So D should be float, then cout D. Let's run it. Now let's work with vectors. A vector basically is like a table of values, an array of values that has a specific data type. So here we're declaring a vector of type string. We need to include vector within among the libraries so that it would work, okay? Because it is a different library. So vector string planes, here we have a vector of planes. 3 different types of values are stored within that vector. Another vector, it has integer values, so the data type stored within this vector is integer, okay? It has 3, 4, 5, okay. Let's say 9 values. In order to insert another value within this vector, okay, you type the name of the vector dot pushback. Pushback means push a new value to the end of the array, meaning that it will be added at the tail, not at the front. So values dot pushback 100 would be stored right after 90 at the end of the vector, correct? So we're creating a function right now that loops through and displays the values, all the values of a vector. So for display, we'll simply call it. It will take a vector and the accessor. By the way, the accessor is where the arguments are taken. by a function, and the caller is actually the name of the function itself. So void display for int I equals 0, I less than, and here how we get the size of the vector, v dot size I plus plus. So see out v of I, like a table, by the way. Another way is v dot at I, add to parentheses I, okay? So v of I. And we're gonna break the line. So we're displaying the values before pushing a new value into this vector, and we're displaying the vector after pushing 100 at the end. You see, you have from 10 to 99, actually it ran the other one without the first, okay? Let's see the size of values. It should give us 9 values here. You see, because we removed the pushback. After pushing back a new value, it will display 10. Why? Because you have another value added at the trailing edge at the end of the vector. Removing a value from the vector. How to remove a value? You simply type values dot pop back. It will remove the last value. So I'm removing two values so that you would see it clearly. He should remove 80 and 90 at the end of the vector. And then we're gonna call display values again, which is the function or the procedure. And you see, we have 80 and 90 are missing. Why? Because we popped them. We removed them from the vector by values.popback. This is the function that actually got rid of them. Another way to get a value is values.at and the position of the value. At 0, it would give you the first value, which is at index 0. Like any other type of arrays, okay? At 1, position 1 value, at 2, value at position 2, etc. Okay? At 4, it would give you the value returned, which is at 4, which is 77, I think. 0, 1, 2, 3, 4, yeah. All right, let's work with maps. A map is actually what is called a key value pair mapping, meaning that you have, just like in an array, a position that is the index number and the value of that index. Here instead you have a key and a value. The key, instead of being an integer, is actually, it can be a string value, okay? To give you an example, so let's say you have different constants, okay? Here we can map a string to a float, string value being the name of the constant, and the float is the value of the constant itself. So map string float physics. Okay, in physics you can have pi being the name of a constant, or gravity, for instance, is the key for that constant, and 9.88 f is the value for that constant. The same thing for, let's declare another one, ATM or atmospheric pressure is 1.02 f, means it is a float value. Another key, and this is how we declare keys within curly braces, couples. As couples, of course, pi is the name of the key, or the key itself rather, and the value is 3.14. Okay, so say out physics, and this is how we call a constant or a key, a value for a key. Okay, you call it by the key name. So ATM, physics ATM, will give you the value 1.4 or 1 point, yeah, the atmospheric value. Okay, So see out physics dot, yeah, okay. Physics.size will give us the value or the size, the number of elements within the physics map, okay? And you see these are the different values. 1.02 is atmospheric pressure. You have pi, you have the size for that map, which is like a vector instead. You have, instead of index, you have a key, okay? It has three constants, three values. 3 KVPs rather, 3 key value pairs to be more accurate about it. Alright? Physics.insert, we're inserting a new value or a new key value pair. The key is phi, that's the constant, so to speak, and its value is 23.4 something float, 45 float. It is a float data type. And to extract it, physics.add phi or physics 2 square brackets phi. This is how you access the value. Now we're gonna work with lists. Basically, lists are a little bit similar to vectors. Instead, the difference is that unlike vectors that are randomly accessible, lists are sequential. So they support a sequential access to elements, not a random access, not a random inner working with elements. Okay? So, of course, you need to include the list library within the libraries, okay, within the include clauses. Again, it doesn't support random access to elements because lists are sequential, unlike vectors. To declare a list, you write list less than equals than. Okay, within these two delimiters, you declare the data type for the list. It can be string, int, float, whatever. Also similar to arrays, so you have planes, Boeing, Bombardier, CRJ 700, Cessna, Embraer. Okay. Let's write a function that will display the different elements within the list that will loop and output all the content of a list, all the items. So void display list of data type string L. This is another way to access the list instead of the classical for int I equals 0 all the way to list.size. For item or string item in list, but this is how you write in list. Item colon L within the list, meaning loop through all the items of the list and display them one by one. Okay? Say out item, and we're creating a space between one item and another. All right, in lists, we can actually insert values at the end or at the beginning of a list. So one way is pushback, which is inserting a value at the end or at the tail of the list, or push underscore front to insert a value at the head of the list. And item planes dot push front item. So the size will increase by 2. Let's display the planes. You notice end item and front item has been displayed and has been inserted according what we've said. Push back inserts at the end and push front at the beginning of a list. In the same manner, we can remove items from the head and the tail of a list. So place.popback, popback will remove one item from the trailing edge from the end of the list and popfront from the head. So respectively from the tail and the head, pop underscore back and pop underscore front will remove one item out of the list. Planes.pop front will remove bowing basically, which is at the front. Or in other words, the first item. As you notice, the two items, bowing and embryo at the front and the end, have been removed.